Hello, in this video we will review the definition of a polynomial and terminology associated with polynomials. If we think of a linear function as having formula L of x equals mx plus b, and the next simplest functions, quadratic functions, as having form q of x equals ax squared plus bx plus c, we can see immediate parallels between their respective forms when we rearrange the addition to get L of x equals b plus mx, or q of x equals c plus bx plus ax squared. It's natural to consider slightly more complicated functions by adding additional power functions. Indeed, if we instead view linear functions as having form L of x equals a sub 0 plus a sub 1 times x, and quadratic functions as having form q of x equals a sub 0 plus a sub 1x plus a sub 2x squared for some constants, a sub 0, a sub 1, and a sub 2, then it's natural to think about more general functions of this same form, but with additional power functions included, which we call polynomial functions. A polynomial function is a sum of multiples of power functions that has the form p of x equals a sub 0 plus a sub 1 times x plus a sub 2 times x squared plus etc. The pattern continues until we get to the last term, a sub n times x raised to the n, where a sub n does not equal 0, and a sub 0, a sub 1, all the way up until a sub n minus 1 are real numbers. This may look overwhelming, but what this really means is that a polynomial is the sum of different terms, and each term involves x to a power, where that power must be a whole number, 0, 1, 2, 3, etc. We often refer to the individual terms as the linear term, the quadratic term, and so on. We use other terminology to describe the polynomial function as well. We'll start by looking at a polynomial in expanded form. P of x equals 24 minus 60x minus 6x squared plus 15x to the third plus 30x to the fourth plus 87x to the fifth plus 60x to the sixth plus 12x to the seventh. When a polynomial is written in expanded form, the terms are the individual quantities being added together. Some of the terms in this polynomial are 24, negative 60x, negative 6x squared, 15x cubed, etc. When a polynomial is written in expanded form, the constant term is the term where x is raised to the 0 power. This polynomial's constant term is 24 because 24x to the 0 is equal to 24. When a polynomial is in expanded form, the coefficients are the numerical values by which each term is multiplied. Some of the coefficients for this polynomial are negative 60, negative 6, 15, 30, etc. Just like a quadratic can be written in different forms, standard, vertex, or factored form, it's possible to write a polynomial function in different forms and to gain information about its behavior and graph from those different forms. In particular, sometimes it's possible to have a polynomial function in factored form. Here we have the factored form of the same polynomial we started with. That means if we were to take 3 times 2x minus 1 times 2x minus 1 times x plus 2 times x plus 2 times x plus 2 times x squared plus 1 and multiply all the factors together, we would get the original polynomial p of x above. It's possible to determine the degree of a polynomial both in expanded form and in factored form. In expanded form, we just identify the term with the greatest power, and that power is the degree of the entire polynomial. So we see from the expanded form that the polynomial has degree 7. In factored form, we have to find the sum of the powers of the exponents to determine the degree. For example, when we start by multiplying the factors together, we get 3 times the quantity 4x squared minus 4x plus 1 times the quantity x cubed plus 6x squared plus 12x plus 8 times the quantity x squared plus 1. And if we imagine multiplying the first term in each of these resulting factors together, the result would be 3 times 4x squared times x cubed times x squared. And simplifying this quantity by multiplying 3 times 4 and adding the exponents together gives 12x squared. Thus the degree is 7, just as we saw in the expanded form of the polynomial. The leading coefficient is the coefficient associated with the degree of the polynomial. In both forms of the polynomial, we see that the coefficient of 12 is associated with the degree of the polynomial. Thus, the leading coefficient is 12. The zeros of the polynomial are any values of x for which p of x equals 0. This is another way of saying the x-intercepts on the polynomial's graph. When a polynomial is in expanded form, the zeros are not usually obvious. However, in factored form, we can use the zero product property to quickly identify the zeros of the polynomial. The zero product property states that if two or more quantities are multiplied together and the result is 0, then at least one of the quantities must be 0. In factored form, the zeros of the polynomial are when 3 times 2x minus 1 squared times x plus 2 cubed times x squared plus 1 equals 0. And by the zero product property, this equation will equal 0 if one of the factors equals 0. So 2x minus 1 equals 0 when x equals 1/2. X plus 2 equals 0 when x equals negative 2. And notice that x squared plus 1 equals 0 when x squared equals negative 1, but that's not possible within the real numbers. So we say the real zeros of this polynomial are x equals 1/2 and x equals negative 2. If we graphed p of x, we would see there are x-intercepts at the points 1/2, 0 and at negative 2, 0. Lastly, when a polynomial is in factored form, we can also determine the multiplicity of the zeros. The multiplicity of a zero refers to the number of times its associated factor appears in the polynomial. For example, the zero of x equals 1/2 is associated with the factor 2x minus 1, which was raised to the second power. That means the zero of x equals 1/2 has multiplicity 2. Similarly, the zero of x equals negative 2 is associated with the factor x plus 2, which was raised to the third power, and that means the zero of x equals negative 2 has multiplicity 3.